So this is another question from IIT JEE PYQ. This is an important question based on the groove in a disc. The concept is based on a groove in the disc. Here is the question: a circular disc with a groove along its diameter is placed horizontally on a rough surface. Okay. A block of mass 1 kg is placed as shown in the figure. So this is an groove. I will draw here. This is an groove. Okay, this is along this diameter, and we have placed a block of mass m here. And what is it given? The coefficient of friction between the block and all the surfaces of the groove is 2/5. That mu is given 2/5, right? The coefficient of friction is 2/5. The disc has an acceleration of 25 meter per second square in this direction as shown in the figure here. Okay, towards left. We have to find out the acceleration of this block with respect to the disc, and it is given that this cos theta is equal to 4/5 and sin theta is equal to 3/5, right? So I am assuming that you guys know what is the meaning of this groove and how this mass is placed in this groove. So when we place this block of mass m in the groove, there will be two surfaces in the contact of this mass of this groove. ये surface, ये जो block है m mass का, ये इस ग्रूव के टू सरफेसेस के साथ कांटेक्ट में रहेगा. सो इसके ऊपर दो नॉर्मल फोर्स लगेंगे. अगर मैं इसके ऊपर जितने भी फोर्सेस लग रहे हैं वो बनाऊँ, हाउ मेनी फोर्सेस आर एक्टिंग ऑन दिस ग्रूव, सॉरी ऑन दिस ब्लॉक ऑफ मास m, then there will be one force acting in the downward direction, that will be the weight of this body mg. One force is the weight of this body, that is mg, right? And one force will be the normal force due to this lower surface contact with this block of mass m. ये ब्लॉक ऑफ मास m है, ये लोअर सरफेस से जब कांटेक्ट में होगा तो अपवर्ड डायरेक्शन में परपेंडिकुलर टू दिस प्लेन एक नॉर्मल फोर्स लगेगा. उसको मैं बोल देता हूँ नॉर्मल ड्यू टू दिस लोअर सरफेस. ओके, सो ये डायरेक्शन हो गई नॉर्मल की, जो लोअर सरफेस के कांटेक्ट की वजह से आएगा. नाउ in this disk frame of reference, when this disk is moving in this left direction with an acceleration of 25 meter per second square, then in this frame of reference, disk frame of reference, there will be a pseudo force acting on this mass m, that will be equal to mass into acceleration of this frame, that is equal to a. So a I will substitute it later. The value of a is 25 meter per second square, right? So this is the value of MA here. Okay, so one more normal force will be acting on this body, that will be in the direction like here, in this direction. That normal force is, I am calling it NS. S means it is due to the contact with the side surface of this groove. ये साइड वाले सरफेस से जब कांटेक्ट में आएगा, मैं ऐसे डिनोट कर देता हूँ उसको, इस वाले सरफेस से जब कांटेक्ट में आएगा तब इसके ऊपर एक नॉर्मल फोर्स लगेगा, दैट आई एम कॉलिंग इट NS. ओके, सो इट इज़ द नॉर्मल एक्टिंग ड्यू टू द कॉन्टैक्ट विद द साइड सरफेस, एंड दिस इज व्हाट, इट इज़ द नॉर्मल फोर्स एक्टिंग ऑन इट ड्यू टू द कॉन्टैक्ट विद लोअर सरफेस. ओके, तो दो नॉर्मल फोर्स आ गए हमारे पास. सो इन दोनों की वजह से इसके ऊपर फ्रिक्शन लगेगा. अब फ्रिक्शन की डायरेक्शन क्या होगी उसको मैं ऐसे डिनोट करता हूँ, लेट मी कॉल इट, एक फ्रिक्शन की डायरेक्शन लगेगी इसके ऊपर इस डायरेक्शन में, उसकी वैल्यू मैं लिख देता हूँ NL. ओके, ये हो गया, इट इज़ ड्यू टू द नॉर्मल रिएक्शन दैट इज प्रोड्यूसिंग ड्यू टू द कॉन्टैक्ट विद द लोअर सरफेस. ओके, सो इस नॉर्मल मल्टीप्लाई दिस म्यू, दैट आई एम कॉलिंग फ्रिक्शन ड्यू टू दिस लोअर सरफेस. ओके, सो इसको डिनोट करता हूँ मैं FL से. सो दिस इज द वैल्यू ऑफ FL हियर, दैट इज फ्रिक्शनल फोर्स ड्यू टू द कॉन्टैक्ट इन द लोअर सरफेस. एंड एक नॉर्मल हमारे पास है ड्यू टू द साइड सरफेस. सो वन मोर फ्रिक्शन फोर्स विल बी देयर, दैट विल ऑल्सो बी along this surface, and that friction force I am calling friction due to this contact with side surface. Okay, and let me assume this block M is moving in this direction, lower direction, with an acceleration AR. AR means that acceleration of this block in the frame reference of this disk. Okay, disk. So I will write here, this AR is the acceleration of this block, acceleration of block in disk frame of reference, disk frame of reference, okay. So here I will resolve these forces along this motion and perpendicular to this line of motion. Then we will be writing the equation of motion and we will be solving it. Okay, so along this line of acceleration, this, if this angle is theta, then this angle will also be equal to theta. Okay, so if I take the component of this MA along this line, then that component will be equal to what? MA cos theta. Okay, and one component will be perpendicular to this line of motion, that will be equal to MA sin theta. Okay, so here if I write the value of NL, now I have to write the equation of motions. The value of NL will be equal to what? The normal force due to the contact with the lower surface. This NL is balanced by this mg force here, so the value of NL will be equal to mg. Okay, now what is the value of this normal force due to the contact in side surface? That is what? NS. That will be equal to what? This MA sin theta. MA sin theta, right? So what will be the value of frictional force due to the contact in lower surface? That will be what? Mu into this NL. That will be equal to what? Mu into mg. Okay, and what is the frictional force due to the contact in the side surface? That will be equal to what? Mu into this normal force due to this contact in side surface. That is equal to what? Mu into MA sin theta, right? Now I have to just write the equation of motion. Now I will draw this free body diagram again here along this line of motion. This is our block here. This is our block of mass M, and a force is acting in downward direction, that is what? MA cos theta. Okay, and two frictional forces are acting in backward direction. One is FL and one is this FS. Okay, and this block is moving with an acceleration AR. That AR is what? The acceleration of this block in the disk frame of reference. Okay, so now I will write the equation of motion here, that MA cos theta minus this FL plus FS, that will be equal to what? Mass of this body multiply this acceleration AR. So this is our equation of motion. So we have to solve this equation for this value of AR. So I will substitute all the values here. MA cos theta minus the value of FL is what? Mu mg. So it will be mu mg. Okay, minus the value of Fs is what? Mu ma sin theta. Mu ma sin theta is equal to mass of this body into AR. So mass will be cancelled out on both sides. So AR will be equal to what? AR will be equal to A cos theta minus mu into g minus mu a sin theta. Okay, so let me substitute all the values here. The value of acceleration is given in the question, that a is equal to 25 meter per second square. Okay, and the cos theta is 4/5 and sin theta is 3/5. Multiply 25 multiply cos theta is 4/5 minus the value of mu is what? 2/5. Value of mu is 2/5 multiply the value of this g is what? 10 minus the value of mu is 2/5 multiply this acceleration 25, multiply sin theta is what, 3 by 5. Okay, so let me cancel all the terms. This will be 5 and it will be 2 here, and this 5 means 25 will be cancelled out. So we will write here 5 multiply for 20 minus 2 into 2 4 minus 3 into 2 6. That means 20 minus 10. So acceleration of this block with respect to disk frame of reference will be equal to 10 meter per second square. Okay, so this is our answer for this question, that this block will be moving with an acceleration AR is equal to 10 meter per second square in this disk frame of reference. Okay.